Hello, everybody. It's me again, Rich Andre. And today we're going to be talking about the mysterious triboelectric effect. Okay, so I'm going to ask you a question. Have you ever used a balloon and just rubbed it on your head, and then your hair, okay, your hair just started spiking up? It just started getting a little bit it started being attracted to the balloon, okay, like your hair is physically sticking to the balloon after you rubbed it a little bit on your head. If you have, then this is the explanation for that, okay. But the triboelectric effect is very vast. It happens in a lot of things in matter, okay, and it's because of one property of matter that we're going to be talking about, which is, okay, charge. So the triboelectric effect mainly happens because of what we call a charge. So what is a charge? Okay? When you think about a charge, you're probably thinking something like your iPhone charger, your phone charger, your laptop charger. And you would be correct on that. Because every single one of those relate to charge. And so does the triboelectric effect. Okay? And charge mainly boils down to, you say, the subatomic particles that we have, which are protons, okay, which many of you may know, which are protons, neutrons, electrons, all of that, all of those kind of things. Okay? And how does charge relate to subatomic particles? Well, if you guys would know, if you guys already know, inside an atom, inside the nucleus of an atom, we have protons, neutrons, and outside of the atom, okay, outside of the atom, let's say this is the nucleus. Uh, wait, let me check. So let's say that's the nucleus, and these are electrons, okay? So you have valence electrons and just generally electrons coming around and swinging to different places, like it's orbiting the atom, okay? And inside the nucleus, we have protons and we have electrons, okay? And everything that you see today, okay, everything in the whole universe is made up of atoms. Everything. Just like your hair, okay? So let's go back to the example that we made earlier. Your hair sticks up to the balloon after you rub the balloon onto your head. And that's because of these subatomic particles. Okay? Mainly the electrons. So when you rub a balloon, when you rub the surface of the balloon on your head, inside, okay, when we zoom in to the very microscopic scale, you can see that inside your hair, okay, your hair is obviously made up of atoms. As we stated earlier, everything is made up of atoms. And the atoms on your hair, the atoms that make up your hair, the electrons on your hair strands, okay, when you rub the balloon on your head, the electrons basically transfer to the surface of the balloon. Why is that? Because you are creating friction. Okay? The balloon, okay? The balloon is made up of atoms as well. So the protons, the subatomic particles that are on the balloon are attracted. Okay, so you guys know, okay, you guys did know the general principle that like charges, okay, like charges, just like two protons, they repel each other. But opposite charges attract. So we have a positive and a negative. They attract each other. And that same principle applies here. We have protons on the surface of the balloon that are actively, getting, they're actively ripping apart or tearing or extracting the electrons from your hair. And that's what makes it, that's what it makes it stick to the balloon. You see? Because like charges repel, as I said earlier, and unlike charges or opposite charges attract. So when you have protons here, when you have electrons that came from your hair on the surface of the balloon, it attracts the protons on your hair as well. So there's some kind of attraction happening, and that is exactly why the kid on the image, the hair on the kids in the image here shows that the hair is sticking to the balloon. Okay, and that is mainly because of charge. Okay, so the very fundamental unit of charge, is what we call a coulomb or a C, or a coulomb, which was named after Charles Coulomb, who was a person in the 18th century that basically contributed to the field of electromagnetism, I believe so. And and that's basically it, So if you guys learned anything in this video, please don't be afraid to subscribe to me. Give me a thumbs up. And if you didn't like the video, give me your honest feedback in the comment section and I'll be sure to read, Thank you guys for watching, and I'll see you in another video. Thank you.